Hi, everybody. Welcome to my channel, Numbers with Nora. This is a math tutoring channel where you can get all your math needs and helps and also homework help. Excuse my voice right now. I'm a little sick, so bear with me. This video is going to be on Algebra 2, and I actually got this from one of my 2Ds for Unit 2 Mastery Check, planning for Unit 2 check in Algebra 2. So we're just going to go off the math homework that she gave me and kind of go through some of those answers. Right, so here we go. Let me zoom in so I can let you guys see what I'm doing. We're going to focus on number 1. Sorry if it's a little blurry. I had to take a screenshot from her homework. So for this one, is this given the graph of function f of x with its key points labeled below. They want us to graph g of x from this function f of 2 times x minus 5 in parentheses on the coordinate plane below. So instead of graphing it, I'm going to show you how you would do this. Right here, I have written out the points that we have. And so we have 2 transformations going on right now. The first transformation is going to be this 2. And this, since it's being multiplied by my whole function, it's actually going to be a vertical stretch. Okay, and I know it's vertical because it's outside of my parentheses or my grouping symbols. And then also I know since my A is more than 1, I know it's going to be a stretch. Okay, and like I said, it's a vertical stretch, so we're dealing with our vertices. Okay, or with our y coordinate. So we know our x is going to stay the same. And then whatever my A value is, which in this case it's 2, going to be multiplied by my y value to give me my new location. But then we also have another transformation right here. My x is getting subtracted by this 5. This is going to be a horizontal transformation to the right, okay? Because we always think about the opposite when we're inside of our grouping symbols. And so horizontal deals with our x's, so that means that we have to take our x and add a 5 to it at the same time to sit there and get to our new point for our new graph, g of x. Right. So we have to sit there and do those 2 things in order to get our new point. So I'm only going to do 3 of these points just for the time's sake. So remember, for our x, we do -5 plus 5, which is going to give me 0. And for my y, we want to multiply it by our a, which is 2. So 3 times 2 is going to give me 6. That would be my new point on my g of x graph. For this one again, for my x coordinate, I want to add 5. So 5 plus -1, that's going to give me 4. My y coordinate, I want to sit there and multiply it by 2. 2 times -1 is going to give me -2. For this coordinate again, I want to add a 5 to it for my x to account for my horizontal shift. So that's x plus 5. That's going to be 6. Okay. And then 2 times 0 is just going to be 0. And I do the same thing for this point right here. For my x, 4 plus 5, that's going to give me 9. And then 9 times a positive 2 is going to give me -18. All right, so that's dealing with our shifts. Again, down here, I have this graph that helps me. If you're not familiar with it, it tells you what kind of shift you're going to have, and then also what you're going to do with your coordinates in accordance to that shift. So if you could take a screenshot of this and try to memorize it, or try to get familiar with it. And the more familiar you get with it, you notice what's going to be your horizontal shift, what's going to be your vertical shift, what's going to be your reflections, and it's also what's going to be your stretches and compressions. Right? So that's where I got how to solve for 1. Right, so let's go ahead and look at 2, and you would graph those new purple coordinate points on your graph below. So now let's look at 2. For 2, they want us to write the equation of an absolute value function. So remember, the parent function of our absolute value function is just going to be y equals absolute value of x. And so I want to sit there and look at the transformations that have happened so far. I noticed that I did have a flip over the vertical axis because usually our parent function of our absolute value function starts at the origin. So that would be like our parent function. So I notice I do have a flip. So I know that I am going to have a negative being multiplied by my grouping symbols. Now let's look at our slope. Usually our slope for our parent function is 1 to 1. So it's rise over 1, run. I go up 1 over 1, up 1 over 1. That's usually a slope of 1. And that's how we find our A value, or what our grouping symbols are being multiplied by. For this one, I can sit there and find my slope by going down 1, 2, 3. Oops, sorry. Because I'm trying to get from this point to this point. So I go down 1, 2, 3, 4, 5. So I go down 5. Okay. So that's an ugly 5. And then I run 3. 1, 2, 3. I run 3. Right, so we do our difference at y's over our difference at x. So that's going to be negative 5 over 3. All right. And then in my grouping symbols now, I could sit there and do my horizontal shift. For this one, from the origin, it looks like I went to the left 1, 2, 3, 4 times. So remember, when we go to the left, we do the opposite. So that's minus 4. And it looks like from our origin, I moved up 1. So that's plus 1. So that's going to be my new function in accordance to my parent function of my absolute value. Right, and as you see, this student right here, or my 2D, she did a good job. Wrote her answer out right here. So let's go ahead to number 3. For number 3, they're asking us to solve for x. Again, this is an absolute value. So when we solve for x and we're dealing with absolute value, do not make the mistake of distributing whatever's being multiplied by your grouping symbols through. You cannot do that with the absolute value function. Okay, so the first step we want to do is isolate our grouping symbols. We want to get them all by itself. I noticed that my grouping symbol is being subtracted by a 5. So let's get rid of that 5. Let's add 5 to both sides. Right. I add 5 to both sides. I have 2. My absolute value, x plus 7. Absolute value. 11 plus 5, 11, 12, 13, 14, 15, 16. I'm not done isolating my grouping symbols. I want to divide both sides by 2. So then I'm going to get absolute value of x plus 7. Absolute value equals 8. Right, now that my grouping symbols are isolated, for absolute value, we have to account for the positive and the negative. So what I'm going to do is set up one equation where I have x plus 7 equals the positive value of 8. And then I'll have another one, x plus 7 equals the negative value of 8. And that's just accounting because absolute values can have a negative or a positive inside. So now I just want to solve for x. I minus 7 from both sides. I have x can equal positive 1. Oops. And then also I minus 7 from both sides on this one. So 8, 9, 10, 11, 12, 13, 14, 15. X can equal negative 15. Those are my two values that x can be. And as you see, my 2D right here did her work. very well and has the same answer down here. Right, so let's go on to number 4. This one is solve for x. Again, I want to isolate my grouping symbols before I do anything like separating them. So I want to sit there and isolate this. If I graph this, this would be a parabola. So again, I want to sit there and add 5 to both sides. When I add 5 to both sides, I'm going to get 2 in parentheses, x plus 7. In my parentheses squared. And this is going to equal 16. Now I want to divide both sides by 2 again because I want to isolate my grouping symbols. Then I'm going to have x plus 7 squared equals 8. Now you want to sit there and get rid of that square. To get rid of that square, I would square root both sides. When I sit there and square root both sides, I do have to account for a positive and negative. So this would become x plus 7 equals plus or minus square root of 8. And I want to isolate my x. So I subtract 7 from both sides. I have x equals plus or minus square root of 8 minus 7. And I don't want to stop here because I notice I can sit there and break down my square root more, right? So I want to think of 2 numbers that multiply together to give me 8, and one of those 2 numbers are going to be a perfect square. So that would be square root of 4 times 2. Using the square root property, I can break those apart. Square root of 4 is going to be 2. That 2, I do not have a square root for 2. 2 is not a perfect square. So then I would just have plus or minus 2 square root of 2 minus 7, and that's going to be my final answer. I could break these apart if you're asking for 2 different x's. And you would have x equals negative 2 square root of 2 minus 7, and x equals positive 2 square root minus 7. All right, let's go on to 5. I'm just going to run through 5 really quick, and you can look at my student's answers right here. She got it pretty well. Again, we're sitting there graphing f of x and g of x, and we're going to see where they intersect. So right here, our first one's going to be a polynomial, right? Notice our polynomial is going to be opening up because I don't have a negative for my x squared. And then also, it would be easier if we just sit there and put this in the standard form, the form of y equals a in parentheses x minus h squared plus k. Right, and then we'll be able to identify our vertex and sit there and use plug and chug to sit there and find other points on our parabola. So for doing this, we have to use completing the square. So let's go ahead and complete the square on f of x. So for this one, I'll have y equals x squared minus 8x. And I'll leave some space because then we want to sit there and have this as something we're going to factor. And on the outside of our parentheses, we put our constant, which is 11. So for this one, it's going to be easier because right here, my x squared, my coefficient for that is 1. So what I'm going to do is use b over 2, right? In this case, my b is negative 8. I divide it over 2, and I square it. And I want to take this, and I want to sit there and add it to the inside and subtract it from the outside of my parentheses. So then I'm going to have y equals x squared minus 8x And then this is going to be plus, or I can leave it as that. 2 minus 8 over 2 squared. I'll do plus right here. My apologies, because we added to the inside and we subtracted from the outside. I'm going to go ahead and erase this right here, so I have room. So plus 11. I'm subtracting my negative 8 over 2 squared. All right, so then I could sit there and write this differently. If I wanted to factor this out, I could, because that would be like negative 4 squared. So I have x, and we also listen to this sign right here, minus 4 squared. If I sit there and do this, 8 divided by 2 is negative 4. Negative 4 squared is just going to give me 16, or negative 16. So I have negative 5. That's plus 11. Minus 16 is going to give me negative 5. And right here, like my student did, she graphed her vertex of her parabola, which is 4, negative 5. So over 4 down 5. And that's how she got this point. And to find the other points, you can plug and chug. Now finding our g of x, which is our absolute value function, you listen to your signs. So we flip. Starting from here, we flip, so we know it's going to be facing upside down. From our origin, we're going to go to the right 4, and then up 7. And then we know our slope is going to be just 1 or negative 1. So we go down 1 over 1, down 1 over 1, down 1 over 1, until we sit there and hit where they cross. And the same thing on the other side, down 1 over 1, down 1 over 1, down 1 over 1, and we hit right there. Those coordinate points that you hit are going to be 1 and 4 and 7 and 9. If you have any questions on this one, put a comment in the comments down below, and I can explain it a little bit more offside of the video. This is our last one we're going to do. This is number 7. This one sits there and says to write the quadratic function in factored form first, then in standard form, and then in vertex form for the given graph. So for this one, I'm going to have negative 5, 0. Let me write these out. Again, I'm sorry, it's blurry. I'm taking this from another student's screenshot. And then I have 2.5. Comma 0, just so you guys can see that a little bit better. Now, instead of writing this as 2.5 comma 0, I'm going to write it as a fraction. It's kind of easier to deal with fractions versus a decimal. So as a fraction, this 2.5, I believe 2.5 as a fraction is going to be, sorry, I'm having a brain fart, 7 over 2. And then comma 0. All right, so the first thing we want to do is write this in factored form. Factored form is when we're just taking our y-intercepts and multiplying them together. So what you can do is sit there and take x. My x right here is negative 5. Take x, set it equal to negative 5, and then solve. So you have 0 on one side. So I'd add 5 to both sides. So x plus 5 equals 0. And that's our first binomial. And you would do the same thing with this one. So I have x plus 5, y equals x plus 5. And then I would also have x minus 7 over 2. Now still, I want to write this a little bit neater. Instead of keeping it like this, I want to get rid of that 2. So another way I can do this is imagine if I'm multiplying this by 2 to just have it neater. So then I would have y equals x plus 5. And then multiply this by 2, 2x minus 7. That's the same thing. I just wrote it in a different way so I don't have to deal with fractions. Now for my standard form, I'm just going to sit there and use FOIL to sit there and find my standard form. I know a lot of people like first, outer, inner, last, FOIL differently. What I like to do is I like to take my first term and multiply it by everything in my second binomial, 2x minus 7. And then everything for my second one, plus 5. Multiply it by all my second binomial, 2x minus 7. Now I'm going to distribute that through. When I distribute that through, I get 2x squared minus 7x. Oh, my apologies. 2x squared minus 7x, yeah. 10 plus 10x minus 5, 10, 50, 20, 25, 30, 35. So then I get 2x squared. 10 minus 7 equals 3x. Minus 35. Let me double check my work because something looks off here. Let me make sure that was a plus 5. Mm-hmm. 1, 2, 3, 4, 5. Yep. And 1, 2.5. Somewhere 2, I believe that's right. And x plus 5 and x minus. Yep. I believe we're right. And then FOIL this out. 10 minus 7 equals 1. Positive 3. Yep. All right, so that's going to be my standard form. And now we're going to sit there and complete the square for this one. So then I have y to complete. So this is the one answer for the standard form. This is the other answer for the factored form. And now we're going to do the vertex form. For the vertex form, I want to sit there and add my constant to the other side, plus 35 equals, and I have 2x squared plus 3x. Now the deal is here is we want to sit there and do completing the square on the right-hand side, and then we're going to sit there and add something else to the left-hand side. So for completing the square, right now we'll focus on the right-hand side. So I have y plus 35. I want to sit there and make it so my x squared coefficient is 1. So I'm going to pull out that 2, and I have x squared plus 3 over 2 because I pulled out that 2. And if I distribute that 2 back in, I'll get what I had above. And then leave some space because we're completing the square and we have to add something to here. When I complete the square, I have my b over 2. So I have 3 over 2 because that's my whole b. And then divided by 2. So I'm dividing fractions here. When I divide fractions, I multiply it by the bottom reciprocal, which is 1 over 2. And then I get 3 over 4. And then remember, we have to square this. Right? So this is going to be plus 3 over 4 squared. All right, let me write it out all of the way. 9 over 16. Now, what I'm going to add to the other side, it's almost like if I had to distribute back this 2, because we have to account for that 2 that's being multiplied by here to add to the other side. So I have 2 times 9, which is going to be 18 over 16. 18 over 16. That's just going to simplify down to 9 over 8. Over 8. All right. And then we complete the square. When we complete the square, I listen to this sign right here, which is a plus. So I have x plus, and remember it was at 3 over 4. 3 over 4 squared. And then if you're confused on that one, I'll try to make another video about completing the square, because you're going to see that a lot in this chapter. Then right here, I just add these 2 fractions of y equals, you want to get common denominators. So if you want to put this over 1, so our common denominator would be 8. Then you cross multiply. 9 times 1 is 9. 35 times 8. Add that together, you get 221. Sorry, I don't know why I put an equal right there. It's supposed to be a plus. And then equals 2 in parentheses x plus 3 over 4 squared. And then we just want to isolate our y. So our final answer would be y by subtracting this 121 over 8, 2 x plus 3 over 4 squared minus 121 over 8. And that would be our final answer. If you do want to turn this last fraction into a mixed number, you can go for it. But that's as far as I'm going to go with this one. Now for this one, since I'm running out of time for number 6, it says to algebraically solve this equation. If you'd like to see how this one is done, leave a comment below, and I can sit there and reply to you directly on exactly step by step how we would sit there and solve this using algebra. Right. So again, I want to sit there and say thank you so much for tuning into my channel. If you have any more homework questions or would like further tutoring, please subscribe or leave a message in my comment section. Thank you.